Hello everyone, myself Lois Sai, studying 2nd DCA, roll number 19BQ1A0404. Now I am going to give seminar in 3 subjects: random variables and statistic processes, analog circuits, ultramagnetic fields and waves. The first subject is random variables and statistic processes. The topic in the random variables and statistic processes are noise. Introduction to noise. Noise may be defined as an unwanted term of energy which tends to interface with the proper reception and reproduction of transmitted signal. In receivers, several electrical discharges produce noise, and the modifying of a required signal is in an unwanted form. Effects of noise. In case of the radio frequencies, radio receivers, noise may produce wish-type sound in the output of the loudspeakers. Similarly, in TV receivers, noise may produce sound which become superimposed on the picture output. Noise may cause several mathematical errors in computation. Finally, we can say that the noise may be affect the performance of the communication system. The classification of noise is done in 2 types: internal noise and external noise. Internal noise: in this type of noise, which is generated internally or with the system of our receiver, it may be treated as or minimized by proper design. Internal noise may be classified in 5 types: 1. Short noise, partition noise, low frequency or flicker noise, high frequency or transmit noise, and finally thermal noise. External noise: it is the type of noise which is generated externally or without the system, is known as external noise. External noise may be classified in 4 types: atmospheric noise, solar noise, industrial noise, man-made noise. Resistive or thermal noise source. The noise generated by resistors is thermal noise, and the noise power Pn equal to kTB watts, where K is Boltzmann constants 1.88 into 10 power minus 3 joules per coulomb. B is bandwidth in Hz. T is absolute temperature in Kelvin. From this voltage Vn equal to square root of 4R kTB. Power spectral density, power by 2 into B. Power spectral density is equal to 2 kTr. Effective or equivalent noise temperature. The noise temperature with respect to the noise power or power spectral density is known as noise temperature. Tn equal to Pn by Kv. Arithmetic noise source or effective noise temperature. Vn square equal to Vn1 square plus Vn2 square. The arithmetic noise source Tn equal to T1 R1 plus T2 R2 by R1 plus R2. Now the second subject is electromagnetic fields and waves. The topic on the electromagnetic fields and waves are conductors and dielectrics. In the electromagnetic materials are roughly divided into 2 categories: conductors, dielectrics or insulators. A conductor is a material which converts movable electrical charges. In metallic conductors such as copper or aluminum, the movable charged particles are electrons. Through the outer surface, they can, though in other cases, they can be ions or other positively charged species. Dielectrics and as insulators. An electrical insulator is a material in which electrical current does not flow freely. The atoms of the insulators having bound electrons which convert readily move. Ratio sigma by omega t. The ratio sigma by omega t is called a dissipation factor D of the dielectric. As dissipation factor is the come as the power under the dielectric. Actually, power fraction is given by Pf equal to sin phi, where phi equal to tan inverse D. Dissipation factor and power factor differ by less than 1%, where with their values are less than 0.15. Most materials used in radio are regulated either to pass conductor currents readily or to present the flow of conductor currents as completely as possible. For this, most materials will fall into either the good conductors or the good dielectrics. Hence, the sigma by omega t equal to 1 can be considered the dividing line between the conductors and dielectrics. For good conductors such as metals, which have much greater ratio and high frequency spectrum, sigma by omega t much greater than 1. For the good dielectrics or insulators, the sigma by omega t is very much less and less than the unity in the ratio frequency range. Sigma by omega t is much less than 1. For example, for mica at audio or radio frequency, sigma by omega t equal to 0.0002. But some materials, just like earth, which is a conductor, whereas conductors in one part of the frequency range, but as the dielectrics in the other part of the frequency range. From the third Maxwell equation, delta cross H is equal to J plus JD. The first term on the RHS, J is the conduction current density, and the second term JD is the displacement current density. The ratio of sigma by omega d is the ratio of conduction current density to displacement current density of the medium. In the factor sigma by omega t, sigma related to conduction current density and omega t related to displacement current density. The third subject is analog circuits. The topic in analog circuits are tuned amplifiers and single tuned amplifiers. Tuned amplifiers. These are the amplifiers that are employed in the surface of tuning. Generally, tuning means selecting. The process of rejecting several frequencies and selecting a particular frequency is known as tuning. Simply, the amplifier circuit whose conductor terminal where collector terminal is replaced with tank circuit, then the given amplifier is tuned amplifier circuit. Tuned tank circuit will assess the frequencies that particularly is known as resonant frequencies. Resonant frequency FR equal to 1 by 2 pi root LC. Advantages. Usage of components such as L and C will reduce the power loss. Selectivity and amplification of desired frequencies is high. Single tuned amplifier. An amplifier with the range tuned in the tank circuit or called terminal is called single tuned amplifier. The values of capacitance and inductance of tuned signal are selected such that its resonant frequency is equal to the frequency to be classified. Operation. The high frequency signal that has to be amplified is applied across the input. By varying the values of L and C, we should make the tank circuit frequency equal to the input frequency so that the storage tank circuit offers high impedance to the input signal such that it produces the high output across the tuned circuit. High impedance is offered only for the tuned frequencies. For remaining frequencies, the low impedance can be applied. Thank you.